The function f of x is defined by f of x is equal to x squared plus 6x plus 5, x belonging to a set of real numbers, x greater or equal to a for some constant a. Determine f to the minus 1 of x, which is the inverse function, and state the least value of a for which the inverse function f to the minus 1 of x exists. Okay, so if we write down the function, now the domain of this function would normally be all real numbers, but if we do that, the function is many to 1. Now for a inverse to exist, then we would have to restrict the domain, so we'll have to have x value bigger than some value called a, which we'll find in a minute. Right, if we set about trying to find the inverse function, and we let y be equal to x squared plus 6x plus 5, and then we complete the square. So we take half of the 6 to get 3. We're going to write y is equal to x plus 3 all squared plus 5. But doing this process here, we have added in 3 squared, which is 9. So here we will need to take 9. So this becomes y is equal to x plus 3 all squared minus 4. Now, one of the purposes of writing this like this is that at minus 3 minus 4, we have a minimum point. And that's quite important in determining this value here, which will come back in the second part of the question. Right, carrying on. If we add 4 to both sides, we now make x a subject. So we get y plus 4 is equal to x plus 3 squared. We then take the square root. We're just going to take the positive square root, because otherwise it won't be a function. So we're going to have the square root of y plus 4 is equal to x plus 3. And therefore x is going to be equal to the square root of y plus 4, take away 3, taking 3 from both sides. And then normally we write the inverse function in terms of x. So we've got f to the minus 1 of x, square root of x plus 4 minus 3. Now, for this to work, this can't be negative, so we have to take values greater and equal to minus 4. But that's not my value of a. I need to restrict this one so that I can get this. Well, the way to look at this is if we look at the graph. So here we have the graph of the original function. This is my value of a here, because this is the function x plus 3 all squared minus 4. So at minus 3 here it starts. Now if we don't do this curve will go up here, and then on the inverse version, which is the red one, will come around here, and therefore that would be a one-to-many relationship, which is not a function. So x must be greater than r, x must be greater than minus 3 on the original function for this inverse to exist. And therefore a is equal to minus 3. In the inverse function, we cannot put in a value of x less than minus 4. Okay, in order to get the inverse function from the graph of the inverse function from the original function, all you need to do is reflect it in the line y is equal to x. If you're using graphing software, you must make sure you've got equal aspect axes. Okay, so this has been a video to show you how to find the inverse function of a quadratic once you have restricted the domain. The reason for restricting the domain is that the original function, if you don't, is a many-to-one function and inverses do not exist. Okay, I hope you've understood, and I thank you very much for watching.